Hello, everyone. I think that we're about to start the meeting in just a few minutes. We already have some people in here, so let's wait for more people to join. We'll give them a couple more minutes and then we start. So, okay, I think we still have 1 more minute. I think this screen is much nicer than our faces. Good. So it's 1 minute to 6. Nice. So 6 o'clock. Thank you very much, everyone, for joining today. Today we have a very exciting topic. So I'm going to introduce you to Christian, who is going to be taking us through the presentation. Just briefly, the topic of today is estimating project risk-based contingency using different tools. In this case, we chose R and Python. And the idea is to present how the tools can be used, and you will see some examples. And hopefully this will be an interesting presentation for all of you. So I'm going to start with the introduction. We have as our guest speaker and a very professional cost estimator, Christian Ramdor. He's the lead cost estimator at Ineos in Europe. He is also certified estimating professional, and he is part of our AAC DAC technical committee. He is very experienced. He has worked in different countries, so he has international exposure, a long career in cost management and estimating, over 14 years of that, worked in multiple industries, and he also holds a degree of industrial engineering and a master in science from the TU Berlin. As you can see, he's an amazing asset for the association, and of course, he's incredibly well versed into this kind of technologies. Briefly about me, I'm currently the head of cost estimating and cost engineering at Johnson Matthey. I'm the chair of the AAC DAC section. I presented in a few of these events, but this is not about me. This is about Christian. So I'll let you go ahead, Christian, and the floor is yours. So you'll have around 40 minutes, and then at the end, we'll have a small time for questions and answers. Throughout the presentation, please feel free to ask questions through the chat. I'll be checking them, and I will try to make them as interactive as possible. So if you want to interrupt, that's okay. We can talk with Christian, and Christian will be happy to answer your questions. So we'll go from here. So the floor is yours, Christian.
Cool. Thanks, everyone. We have now 17 people have joined to the virtual session this afternoon in Central Europe. So we have a very extensive topic, contingency for this evening, and we have very limited agenda, so very compact agenda, I would say. So I will start with a brief introduction of the state of the art by AAC, what risk classification is. Then we will tackle that down to our technical framework, especially from the AAC perspective. Then I will share with you a 5-step method to calculate project-specific risk contingency. Then I will show how I apply this method to the Monte Carlo simulation using R as a development tool. Then I am handing over again to Luis. We will explain his method for estimating ranging, estimate ranging using Python. And if we are, hopefully we have 10 minutes for answering a question at the end. anyhow, if you can move forward, Luis, to the next slide. Yeah, so don't worry if we are not addressing your specific question during this seminar. So every question will be answered after the session today. So some tips: keep your question clear and concise. And if you can mention specifically the slide where you have the question, that is better, right? So that could be the procedure for the question and answer round here at the end. If you can move to the, okay. So a brief introduction to what is risk classification according to the AAC best practices. So we have the latest best practices, the 117 and the 113, sorry, and they tackle both, and they use this beautiful diagram for risk classification and easily explained. So what we are covering today, I am framing my method to what is here called contingent risk. That is the project-specific risk contingency, the blue bubble there. And Luis will be covering with the Python method the estimate ranging contingency, specifically for cost, so covering inherent risk. But a little bit more about this diagram. So we have these two I think historically approaches to contingency calculation living together. So the blue one and the orange one below. The risk events, the contingency, so risk-based contingency basically is about is all risk events and uncertainties that are below 100%. So technically speaking, right? And the estimate ranging actually it tackles uncertainty that we can say they're 100% probability. Yeah, so biases in the base estimate. So uncertainty on the data in which was based your estimate, right? So. And one layer around that is the project system, right? So the light orange bubble here, which is called systemic risk that we start understanding from John Holman's perspective, right? Which is based on the project system. So risks that are not easy to tackle because they're so embedded in the project system that how to assess them on a quantitative manner might be very difficult. So we have some best practices tackling this, the 113 specifically, how to manage the systemic risk, right? But we are not covering that. We have the intersection here between the systemic risk contingency and the project risk and the project-specific risk contingency on that intersection. So the best practice is try to cover all around. So the orange line here. So that would be the, I would say, state of the art right now. Cost and schedule integrated contingency calculation. But we're not tackling that specific here. So we will be tackling or addressing the blue bubble and the orange bubble below. So if you can move to the next slide, please. Okay, so now framing the scope of work to what is risk contingency. I would say what we need to understand before moving forward to calculating risk-based contingency is understand the expected value method. So it's only a coincidence with this EVM, right? The mostly of us from AC understand that as earned value method, but in this case is expected value method. That is a totally different thing. So here the question that we are trying to answer is how to assess the probability and impact of identified risk, right? That's what I mentioned before about risk events that with a likelihood below 100%. If we move to the right, so we need to understand what a Monte Carlo simulation is, and try to address the question how to assess the uncertainty of the project outcome based on a cost model, right? So Monte Carlo give us the technical tool to simulate the project reality, in other words. And if we move forward below, we have what we need to understand is some basic statistics. If we are more keen on statistics, then is much better, right? Because from all the data that we are producing after the Monte Carlo simulation, we will try to understand that data from a statistical perspective. So we are trying to address the question how inputs and model parameters impact the simulation outputs, right? And one important question that is for the contingency calculation, and that is very, I would say, subject to each organization or project, is how we interpret the confidence level. Every company or every project might have a different risk appetite, and that might be understand as what confidence level, where I position myself in that confidence level, right? At the end, we need to understand this modeling risk dependency. So we're trying to understand how the correlation impacts the accuracy of the model, right? So we are technically understanding risk dependency and how it transfer that into correlation coefficients. You can move forward to the next slide, Luis, please. So this process I'm sharing in this webinar today is the process I have established to calculate this risk contingency, right? It is aligned with several RPs for risk management and contingency calculation, right? I think is well known for every risk practitioner in a project environment. So we start identifying risk, right? You can do that by means of a risk workshop. So in my experience, it's the most common way to identify a risk is having and organizing a risk workshop. Then with the workshop results, or during the workshop, you can prioritize and give priority to the risk for all the project team. Merge risk if it's required. That happens quite common, right? That the risk workshop is kind of a brainstorming session. So you're collecting risk events. Most of them or several identify risk that are not risk events. So I think what is important there is to try to facilitate the workshop and to explain how to formulate and to identify risk properly. After that session, what is needed and required is to assess the probability of the identified risk. And you can also discuss mitigation steps and their cost. And the cost identifier for the mitigation step, you can calculate that and transfer them back to the base estimate. After that, in the second step, we are trying to quantify the risk. And here, so my recommendation would be, my hard recommendation is that by the time of quantifying the risk, would be very useful to have the base estimate frozen, right? Because what you are doing, you are trying to calculate burn rates out from the base estimate in a way to convert schedule impact into cost impact. So in the same session of quantifying risk, it's also recommendable to meet with the project leads in each discipline and trying to figure out the cost impact of every risk. So in my experience, during these risk sessions or these risk assessment meetings, so people tend to talk a lot about the technical scope of the risk, but nobody actually is willing to assess them technically, also more in a cost manner. So it's also very highly recommendable that you have your cost engineer or your cost estimate into this quantification process of risk. Then you need to quantify correlation. And I think that I believe this is quite important to quantify correlation if you expect better accuracy in your results. It is also important because it enables the sensibility analysis. So that needs to be very clear. So without correlation, you don't have a tornado chart with your with all the risk driven that are driving your projects. And also the risk dependency also it simulates or it reflects the reality, right? So you have a lot of intersections and interfaces in the risk environment of your projects, and we will tackle that after this slide. Then we have the step number 4. So when we have all my risk has been quantified, correlation have been assessed, then I move forward for the MC simulation. And what I'm sharing here with you is the script. I will be sharing this script in R, and Luis will be sharing the script in Python to actually make the Monte Carlo simulation, but also it enables you a lot of automation in the process of pre-processing all these data from the risk register, from correlation into the output that you need to calculate, or the output that you need for your contingency calculation. So at the last level is the contingency level. So you have to provide to your project director of your project team a recommendation in terms of contingency, right? So if you are using a coding script, right, it's much easily then to connect all the results to templates to report the results of your all your assessment, all your quantification process, and then you have a very professional outlook of your results, right? That would be the last level. So issue your quantitative risk assessment report, QRA. Okay, you can move forward to the next slide. So first step, identifying risk. So we have here internally at INEOS make some templates, and we have improved them in the run. So the more workshops you have, then you learn a lot from them, right? So we have templates for defining probability, for defining dependency, that are the tables you see at the right. And we have these diagrams to understand and try to normalize a little bit this influence from one risk to another in terms of an error and a typical traffic light signal, right? So that is the idea. People who might be very external to the risk identification process, they might have an idea how to do that easily, like kind of gaming stuff, right? So I think then we move to step 2. So quantifying the risk. So what I have found quite interesting and very useful are these risk cards that are published in the RP65R from 2011. And it's quite interesting how how you can calculate these burn rates. So make so easy at the end to transfer that to your project risk register and trying to convert and transfer the schedule impact into cost impact, right? As this method, it doesn't aim to integrate that directly in the Monte Carlo simulation. That would be kind of the next step, right? But for this step, at least you are covering the schedule impact in your cost, and you're transferring and that to as cost, right? So here in the example, is something that is pretty common. So you get through every of your risk or that you have already prioritized with your project director or your project manager, right? So you have input from your schedule, right? What is the lead time in this case for mid voltage transformer, right? So you define a base estimate, and you have from your contractor or from your experts, right? What is the base? What is the most likely, right? Here would be the lead time given by your vendor, and you have from your electrical discipline lead that provides you with this. The worst case would be 24 months, right? And the worst case 6 months, right? So you can calculate what is the impact on the critical path, for instance, and then you said, okay, what package, what contracting package are being impacted for that? We'll just say, okay, the civil in X days or X weeks, right? And you have your field services, and you have other site running costs being impacted by this schedule delays, right? So, and then as you have for each of those accounts or packages, the weekly or monthly costs, right? You can transfer those weeks into costs, as you see there in the cost impact, right? So that is an example of how to use these burn rates in the risk register for the risk quantification process. Can you move, Luis, please, to the next slide? Okay, and now we move to a topic is not so, it's very controversial, I would say, the topic of correlation. I have been myself also been wrapped into correlation, right? So you can really make false assumptions in estimating correlation, right? So what is important to understand is that we assume that correlation is something to be a guess, but actually you can, if you have a risk system or a risk management system, and where you have risk libraries, and you have historical data from how risk types relate with each other, you can indeed calculate correlation. That is something that I honestly haven't done right now, because it's to get a risk management system in place where you have all contingency and the contingency drawdown and all your changes, and how contingency is related to your risk types, and enough amount of data to calculate that contingency is quite difficult. I think there's some companies in that track. And if you have a quantitative calculation of your coefficients, that would be absolutely the best case, right? But if you don't have, you go by the typical track. You sit together with the risk owners or the expert in each field, right, and try to estimate the coefficient, right? Here are the common assumptions: is how is the dependency, or how the impact of risk A impact the event of risk B, right? So we have a nice discussion when I published the LinkedIn article on this topic. So I got very good questions, and I provide there an example about this for the earthwork, right? So when you are making your soil investigations and you have these bumps, so here in Germany, for instance, and then I gave that example, right? That is quite common in Germany, that during your earthwork you find or you have a, I would say, pretty high likelihood to find some Second World War bombs. That is, so I think if you start looking to the news, like I think a couple of months ago, I think how many people, like 5,000 people evacuating from Cologne because they have to move one bomb discovered during earthwork from the Second World War, and it's a relatively high risk in comparison to other countries. But so what the example is here is you have a mitigation plan, right? So you make your soil investigation, but your soil investigation it covers not 100% of the risk of not finding a bomb, right? But in the remaining risk of that, right? After mitigation, if you indeed find a bomb, right? Perhaps because it's more deeper than what you investigated in your soil, right? Or because your grid was not dense enough or whatever, right? It may change all your assumptions in terms of piling or the earthwork, right? So here you may have, you can set that a risk of finding bumps, right, or finding such artifacts in the ground may impact your other risk from your earthwork package, right? So then you can model that as a very high correlation, right? Yeah, so that is about the topic of correlation. So also my experience with correlation is that be aware of using negative correlation. That is not so you can make some false assumptions, right? So it's important to understand that perhaps the solution is not model the dependency of your risk with negative correlations. So if you have very similar risk, right, it's not that you make a negative correlation, then you are like minimizing the impact of the output, right? So if you have similar risk, the recommendation is to merge them and then make the correlation assessment. Okay, that is to step number 4. Please, if you can move forward. Okay, now would be hands-on on what is, I would say, the core topic of the seminar, like is DMC simulation using a script. Would be here the processing motor in R. That is the typical architecture would be you have inputs, data sets in Excel, right? You can have a single Excel or more Excel, right? With your input data sets. One would be the assess risk log, and second would be your correlation matrix. It gets into your processing motor of R or Python, right? And run this script step by step. And then you got an output that would be the third column here. So after processing all these data, right, you You model the risk event using probability and distribution functions. You have to validate mathematically the correlation matrix, for instance. And in case of not having a correlation matrix, you can take another path, right? So, and then it's run the Monte Carlo simulation. It can easily then plot the contingency histograms and the sensitivity analysis. And then with R and Python both, it's very easy to organize all these data and sending these out to Excel, right? Directly to a template, so like a contingency report or a QRR report, right? Or in the intermediate step where you can post-process all that data and charts. Can you move, Luis, forward to the next slide? Okay, so first of all, I have to give the credit here. So in the script I developed, after quite a lot of time investing in developing the script. So I have to set, first of all, I am not a developer. I am not an R expert. So I have learned quite a lot in the process. But I have to say, if something was useful back then, was artificial intelligence. So I had quite long conversation with ChatGPT about the code. So my experience with refining and enhancing your code and code debugging, ChatGPT make a pretty impressive work, right? So you can co-create your customized script in R or Python with ChatGPT or some other more specific, perhaps development tools based on AI. I have found in this journey a package which is called PRR, that is from Paul Govan, that is aeronautic engineer that have developed several risk models. And this package specifically is called Project Risk Assessment Package. Is pretty well described. And you can have enough, I would say, functions in order to run all to run the Monte Carlo simulation and other calculation within the script, right? So as you see here, the first step in the simulation is to set up the environment. You see at the right here, would be the inputs. You have the table there with the risk. That would be it's a table with the risk. With the ranging of those, right? So with the low, the most likely, and the high values of those risks that have been previously assessed in the step 2, right? Then you have the probability. Normally, it comes from identifying your risk, and after that, refining with the discussion with your risk owners and your project manager. And then you have to give them what is called a PDF. It's a probability density function, right? So it depends how is your package here, the Monte Carlo simulation with this PRR package. You have only 3 types of behaviors that you can model. So triangular, uniform, and normal. You can add that to the PERT distribution if you want. But and then you have your I would say your input from the risk from the correlation matrix, which is on the bottom right side. You also have to define your parameters as always. The number of iteration here is set to 10,000. You can set that to 5,000. So here the processing time, computing time is seconds. So it's any problem to process big data or high amount of data with 10,000 iterations. And for this specific script or for the plots, you need to define the bins as the quantity, the scale of the distribution outcomes of your Monte Carlo simulation. Okay, so if you can move to the next slide. One thing that is interesting from the project risk based contingency is that we are trying here to calculate or to simulate the behavior of the expected value. So we have risk events, right? And risk might arise or not, and summing up a certain probability. So what is happening here under the hood, right, is that we have, for instance, a binomial function modeling this in a binomial way. So zeros and ones that assume at the end your probability, right? So that is happening first. And then you have this behavior, right? This risk occurrence modeled, and then you multiply that by your PERT or whatever distribution you have. You may have a triangular or normal distribution, and then you got your MS, your Monte Carlo simulation results, right? So the idea is that the Monte Carlo in each of the iterations is trying to model this behavior using this risk occurrence simulation, right? And that runs for 10,000 iterations. You can move forward to the next slide, please. So then you have your results, as you see at the left. That is your histogram with your cumulative percentage curve, which is the confidence level, right? Your CDF at the right with the results. So actually, I design all these plots. So I'm using the ggplot function from R, and I am adjusting quite a lot of parameters to get this histogram. So that is something that you get for free in the script if you look at my script. So what a lot of people might be asking is why that's, I would say, not well, where's the bell curve there, right? So that happens actually when you run the simulation using this risk occurrence variable, right? So like for every iteration, you might have a absolute value or a zero, right? When Monte Carlo is like sorting the data, right, from 0 to 100% in this cumulative function, then you have a lot of zeros, right? So you have a lot of hits that are zero. That is what is being there in the histogram that you see on the left, right? So that is something that you may also, if you change the expected value, if you multiply that in a deterministic way, you get a bell curve. I can show that afterwards anyway. So what we have here are the statistical results that you see at the bottom. It's something that you can fully adjust in the R code. And you got the tornado chart at the right? The sensitivity analysis sorted out by the risks that have the most impact on the project outcome, right? And there you have the sensibility in terms of the numeric sensitivity table. Can you move to the next slide? Okay. So, and then you can combine all that to your contingency report. That is something totally up to you, but it's very, you automate the process of creating the data, and you automatize here the template. Okay, I think that is from my side, Luis.
Yes, thanks. So I'll take over from here, and I'm going to move to Python. So I think that the idea of today is also not only to show that there is one tool, it's like there are so many tools that people can use. And in the process also is not only one way to do it, it's like how it works for your organization, the maturity of the organization, and how you adapt the tools to your organization and your experience. In this case, I chose Python because I'm more familiar with Python. I see that Christian likes R. R is more academic. I'm a little bit less academic than Christian. So when I started using this, same as Christian, I had no idea about programming. So I started playing around with ChatGPT, and I had some good mentors teaching me about some stuff. And the first thing will be, don't be afraid of using tools, R, Python, whichever language you prefer, C++, PBAs, whatever you want. At the end of the day, it's not about the tool, it's about how you use the tool. In the case of what I was preparing, I use Python. I also use Jupyter, Excel, Visual Studio. So it's just a bundle that works for me. Doesn't mean that it's the best, but it's what works for me. Also, what I found that at the end was required to achieve what I achieved was to get some intermediate experience with Python. So it means I started using things from scratch, understanding the basic functions, understanding the basic libraries. And there is a couple of libraries in Python that are very, very useful, which is Pandas and NumPy. They help you run all sorts of data interpretation. A decent understanding of statistics. I think that Kristen made a very good point on it. How do you choose a curve? How do you choose a distribution? When is to choose a normal distribution, a triangular distribution, a pair distribution? And actually, there is a very good point in John's Holman book on section, I think that is section 7, that he talks about it. And last but not least, using Excel. That I think that pretty much all of us are familiar with that. So in this case, I decided to go with an estimate line ranging method. So again, this is just an example of the application, but this could also be transferred into a RAND model. So you can convert this easily to be a systemic risk, or this can be a line ranging estimating model, whatever you want to do. It's basically the same principle. It's only that the variables are going to be allocated in different positions. In this case, as I was saying, I use NumPy, Pandas, Matplotlib, Seaborn, SciPy, OpenPI, Excel, and Datetime. So my intent in here was to create an Excel table where I have each line of my estimate. I range each lines of the estimate. I decide which distribution I wanted to apply to all the different estimate elements. This is imported directly from Python, from Excel into Python. I run the report in Python and then feed it back directly into Excel as a report. So again, this was also a very simple example. It's not a system, it's an example of what can be done with Python. The first steps that I had to follow was read and clean the Excel data. So that means the first step you need to understand is how to import data from Excel into Python. There are very good tutorials about it. I selected my distribution. In this case, I chose a triangular or normal distribution because that's what I find is more commonly used in my experience. And I also included some skewing on the both sides, left or right, to make sure that I captured the bias from the people. And finally, I started aggregating at different levels. So it's a very similar process as what Christian was doing, but I was more focused into the estimating part. So that's why Christian was mentioning he's looking into the project-specific risk. I'm looking into the estimated-specific risks. And again, this can be converted into a RAND model that can be also used for general estimation. Now, how does it look like? The code is a bunch of lines. I think that if anyone is curious about the code, we're happy to share both codes, R and Python. You can play with them, and if it works for you, you can just convert into whatever you want. At the end of the day, for me, what I wanted to achieve was a bell curve and a normal distribution. I wanted to get my statistics, which include minimum, maximum, mean, standard deviation, and so on and so forth. I built also, same as Christian, a tornado chart and a sensitivity chart for correlations. So you can see that both methods arrived to a very similar conclusion with two different tools. Christian built a very nice environment around the tool, which is a very cool thing to do, and it's, I think, a very sustainable way to go ahead. And this is something that was helping me to calculate the contingency for my estimates. So in my case, I don't have a very large team at the moment, so it was me running this. So this was tailored for me, and I was happy to do it myself. So this is not something you can roll out to many people.
So Luisa, just a final word. So I have to the script. So I uploaded. I create I think in the community of ACE in the forum, I create a post where I uploaded the entire script, all the instructions how to use it, also the two inputs and output Excel and the R script. So the 3 files are uploaded, also with the PDF with all the instructions. So if you want to use it, just go ahead.
Yes. So I think at the end of the day, what we want to show in here is that there are tools available. You can buy at risk. You can buy any available market tool. That's also feasible. And in some cases, it's probably better than building it yourself, because the amount of errors that I did when I was building this was very large. So I think that the important part is just explore things and understand how coding works. So when vendors come to you, you understand what they're trying to do. Some of the tools available in the market may or may not fit your purpose, or may not fit your workflow. So there are alternatives. And as we were saying, basically, ChatGPT is your best friend. And if you have doubts, you can go to the recommended practices. There is 4308 that talks about systemic risk. So you have a RAN model in there that you can actually convert into an Excel, and then you can run the Excel model directly into Python or R. And there is also another recommended practice, I don't remember the number, that provides information about the different statistics and the different distributions you can use. Also, there is John Holman's book, Chapter 11, Chapter 7. So if you don't have it, John doesn't give me any royalties from it, but I think it's a very good book to read.
Yeah, just to say, so the motivation for me to writing and developing the script was when I think for 2 years my lineup manager, when I asked for the budget for a risk management tool, right? He said because of budgetary restriction, we would not be buying any software for risk assessment. So and that was the motor, the motivation to create the script. So
good.
Okay,
I'm
so
getting I'm getting a couple of questions about the code. So what I'll do is we will share the video on YouTube, and then we will, if you want the codes, can you please just leave your email so we can just share the codes with you directly? Maybe that's just an easier way.
So just to finalize and to wrap up the seminar, the virtual session today, we have 4 minutes remaining. So if we come back to the basis, right, where we have this nice and beautiful diagram with the risk classifications, right? So what we have covered today was 2 types of calculating contingency. One with Python, with the estimate uncertainty, that means risk that are higher than 100% in their probability, and the risk events, so the project-specific risk contingency, which are based on risks that are below 100%, with 2 different approaches and 2 different tools. Here you have, I would say, you have much more RPs than the ones you see here, but I would say the state of the art, which combine all the bubbles of the diagram, is the RP 113 and the RP 117. So one is I would say, the expected value approach, right? The 113. And the other one is integrating the cost into the CPN model, that is the 117, right? However, I think I was thinking in moving forward to this integrating schedule also into the script. So there's a lot of open and there's a lot of space to develop here. So if you have, sorry.
I was just going to move to, should I move to the conclusions?
Last final words. Okay, the conclusion for today would say, so what is the challenge? I think from my point of view is like estimating correlation with quantitative method, right? So try to avoid your project team or project manager misinterpreting coefficients, because that leads to unexpected result on the simulation, and you can get a not expected contingency level. Second, I would say if what I mentioned below, so I think the next steps on the development of this script is to move forward to integrate schedule into the Monte Carlo simulation. So that means not as schedule impact converted to cost, but directly with dates and likelihood inputs into the model as per the RPs 113 and 117. Finally, also is integrating the escalation into the model. So right now I have two models living together, one to calculate the forward escalation without any so in a deterministic fashion, right? I have forecast model there, but I don't doing that on a probabilistic model. So I think that is quite quite interesting, right? Try to merge both model into a single one. And I think the last word, and that is a call for the ICE community to further develop and share these coding solutions. So that is my outlook and challenge here.
We have a few questions. I'm going to throw the one from Jared. And Jared is asking, have you used Python or R in Excel, the Excel add-ins in Python or R in Excel? It may be easier to integrate in organization with existing models and more explainable. Have you done that, Christian?
No, so actually, nowadays, with the latest, I would say, Office releases, you have R in also, you have the R plugin into, so in Excel. Also, you have, for instance, in Power BI, you have the visualization script, or also in the Power Query, you have the you can integrate directly Python and R script. So that is possible. I have not done yet directly on Power Query, for instance. I did that for Power BI. But not for Monte Carlo simulation, but for forecasting. But it's absolutely possible, and you can. So, however, it depends how are your organization policies. In my case, so RStudio is free and is approved by my organization, so it was easy. So the RStudio, you can work with both Python and R, and it's very easy and very intuitive to work with. So it depends, but it's absolutely compatible nowadays with the Office releases, the latest, to integrate both R and Python directly into Excel via Power Query.
I'll say in my case, Jared, we don't use the Python add-in because it's very difficult to get add-ins approved. Normally, they have a lot of scrutiny from IT. And R, same story. So in my organization, as Christian says, depends on the policy. I have to use Python via Anaconda. So it's not directly used there. So hope that answers the question. We have another question from Siddharth. It says, do you adapt this PSR-based contingency approach differently for industries with very dynamic risk profiles like IT or automotive?
I don't say so. Software development is quite different industry than infrastructure or chemicals or like building physical assets, right? But so this project risk-based contingency can be applied wherever you have a risk register assessed in terms of schedule and cost and probability. So that would be the basic ingredients to do that. So I have not seen that on software development. I think for other projects, automotive projects or other kind of project environments, if you have a risk register, then you can build up that and have a contingency calculation based on that.
Good. And I think we cover all questions. So thanks everyone for your participation. Christian, thanks a lot. Very useful material. We have all your emails from the ones that requested the scripts. I'll be sending them to you probably tomorrow or this week later. And if you have more questions, you can, of course, send an email. My email there is wrong, but yeah.
Okay.
That's right. So doesn't matter. If not, you can write Christian, and then Christian can forward also the questions. So, but thank you very much, everyone. I think that this was a very insightful session. Hopefully it was also interesting for you. And yeah, so I'll upload this to YouTube and see you then. Thanks, Christian.
Bye-bye, and thanks for joining tonight. Bye-bye.
Bye-bye.